recording a video. To figure out what our estimate then could be, what I want to do is I want to take a look at how far along 5 is on the journey from 4 to 9. So the journey from 4 to 9 is 5 units long, and 4 is 1/5 of the way. So our estimate then is going to be the lower root and this fraction. We're going to say that root 5 is 2 1/5. Now at this point, Andrew, is that where you turned it into 1 1/4? Or what did you do? How did you get 2.25? You don't remember what you did? Okay. This is one of the fractions that I told you guys to memorize. So you could just stop right here and say, okay, well, 2 1/5, that's going to be 2.2. And now we can check our estimate using our calculator. So I want to know what the square root of 5 is. The square root of 5 is 2.236, which we could round to 2.24. Now, Andrew, your estimate of 2.25 is pretty good. Avneet's estimate, 2.2, also great. This one, it splits the difference. This value is actually 2.236. So these are both totally acceptable, great estimates. Now this guy here, if we're going to estimate the square root of 15, I would do it similarly. I would say that 15 is between 9 and 16, which means the square root of 15 is going to be between 3 and 4. This is 7, this is 6. So it's going to be 3 and 6 over 7. Now 3 and 6 over 7 is kind of terrible because our seventh fractions are nasty. So there are a few ways that we can go about making this thing better. What I'm going to do is now you guys don't have to do it the exact same way. What I would do is I would multiply top and bottom here by 3 to change the fraction ever so slightly. I'm going to say then this is going to make it 3 and 18 over 21. And now this is where I'm going to massage the fraction, and I'm going to say that, well, 3 and 18 over 21 is basically going to be 3 and 18 over 20, which is really quite nice because what that's going to do is I can divide top and bottom here by 2, which is going to give me 3 and 9 over 10, which is going to be 3.9, and that would be my estimate for this question. Now I can go back and I can punch this into my calculator to check how good my estimate is. It's going to be the square root of 15 equals 3.87. 2983346. So my estimate of 3.9, pretty good. If you got an estimate anywhere between, well, I'll say 3.8 and 3.9, you're good. Did anyone do either of these and want me to check it? What do we get as an estimate for the square root of 30? Oh, so a bunch of us didn't do our homework. Sorry? 5 point, that was your estimate? Okay, let's do it. 5.5, oops, delete you. If your estimate was 5.5, that's very good because square root of 30 is 5.477. So that's great. What did you do, Brielle, to get that? Okay, so you said that 30 was between 25 and 49. So that's going to be between, 36. Thank you. So that's going to be between 5 and 6. That's 11. This is 5. So you took 5. Yeah, that's great. That is a great way to do this question. Anyone get the root of 55? What was your estimate for this? 7.4. So 55 is between 49 and 64, so that's going to be between 7 and 8. This distance is 13. Is that right? No, or is it 15? 15. And this distance here is 6. So you did 7 and 6 over 15. Who was the voice I heard? Emma, was this you? Where'd you go from this point? Ooh, yeah. You betcha. Which gave you 7 and 2 over 5, which was 7.4. That's great. That is a great estimate. Sweet. Then for these guys down here, lots of this was just, the first chunk was just punching into your calculator, making sure you can do that. So you were looking for these values. I'm going to round them, 2.236. 15 is 3.87. 30 is 5.47, and this one is 7.41. Again, these are the same set of questions as these to check our estimates. And then these guys here, I wanted you to be able to do without a calculator. You should have gotten 6, 8, 1, and -1. Does anyone want me to do any of those bottom questions? Yes, Aiden. No. For the same reason I wouldn't let Liam leave, I'm not letting you leave now. Why? Because I'm going to teach a lesson. I want you here for the lesson because I don't have to reteach the lesson because both of you have missed substantial time in the last couple weeks. So, flip the page. Let's do the root stuff. Last bit of root stuff. Yeah, last bit of root stuff. And then we've got one more lesson after. Oh, yeah, sweet. Bye. Oh, yeah, no, this is good. Cool. Here we go. So, cube roots is where we're going to land today. If a square root is a number multiplied by itself, blank times to give the original number. For example, the square root of 4 is 2 because 2 times 2 is 4, and the square root of 25 is because 5 times 5 is 25. This is 2. Then the cube root is a number that multiplies by itself how many times? Sorry? 3. And it literally comes from, well, square roots came from the area of a square to find the root of the square. And the cube root is going to be similar. The cube root is going to give you the side length. This is still the root. But instead of the square giving you the area, the cube is going to give you the, what is the side times another side going to give you on a cube? The volume. So the perfect cube, oh, sorry, I'll zoom this out a little bit, is the volume of a literal cube. So the cube root of 8 is what number times itself again gives you 8? 2. Cube root of 8 is 2 because, bless you, 2 times 2 is 4 times 2 is 8. Now the squares don't get quite as big quite as fast. The perfect squares were the diagonal along here. 1, 4, 9, 16, 25, 36, because you're only multiplying a number by itself. But now we're going to start multiplying a number by itself a couple times, 3 times. So the numbers are going to get big quick. The cube root of 64, if you have a reasonable guess, yes, Andrew, it is 4. Because 4 times 4 times 4. 4 times 4 is 16. And then 4 16s is 64. Now, as far as the cube roots go, I don't have a multiplication table for cube roots because if cube roots are related to squares, then it's not a multiplication table that I would have to give you. It would be a multiplication cube. and the perfect cubes would be the diagonal from one corner of the cube through the center to the other side of the cube. That would be awesome and really hard to use. I would love a multiplication cube. If you find one, let me know. And so the easiest way to deal with this is to memorize a set of perfect cubes. The set of perfect cubes that I'm going to encourage you to memorize is just the first 10. It'll make your life a lot easier. The cube root of 1 is, what times itself 3 times is 1? It's 1. Bless you. This one we've already seen is 2. The cube root of 27 is? The cube root of 64 we already saw was 4. 125 is? So then 216 is? 343 is? Interestingly enough, I once had a license plate on my car, had 343 in it. Made it real easy to memorize this guy for me. 512 is going to be 8. 4 on the 4, please, Liam. There's 2 more here. Only one of them is really hard. The cube root of something is going to equal 9. This number is, I just had it, 729. And then the last one is the cube root of what is equal to 10? 10 times 10 is 100. Times 10 again is 1,000. So these are the perfect cubes. Now your calculator is designed to handle these things as well, except they're going to behave a little differently. I've got my Casio and my TI. Get your calculators out, those of you who have one. If you don't, lean over and look at someone beside you who does have one. And I will show you how to use the calculators for this. Then watch. Okay, I'm going to start with I'll start with the Casio. Let's zoom in on the Casio. Now the Casio is kind of unique. It's got a squared button. It's got a square root button. Above the square root button is a button with a 3 there in what we call the index, that little gap in the root. This is the cube root. It's also got this button over here, which is the x to the box. This is how you put any exponent in. And this one is the box root of box. This is how you do any root. So like there are not just square roots and cube roots, there's also 4th and 5th and 6th and 7th roots. You have as many roots as you want. It's the number that multiplies by itself box many times. But the Casio has a dedicated cube root button. To use it, we're going to hit Shift and then that button to access that. So I'll show you on the Casios how that works. So I'm going to go Shift, I'm going to go cube root, and I want 125. Just because that's the one I have on the screen right here. And that should be 5. If you're going to use the box button, we're going to put Shift and that'll be the box root. On this calculator, it opens up an X there. So what I have to do is I have to go on this side of it, and I have to put a 3 there. And then I'd put the 125 over here. It's not 3 times. The 3 takes the spot of the X, and this is going to be the 3rd root of 125. Now, some of your calculators are smarter than this. They actually put a box there, and you can go back and fill in the box. The Casios have a few different ways of demonstrating this, but it's pretty slick. Now, the TIs, for those of you who have or use a TI, there is no square root button. So what you need to use is the xth root, which is that guy right there. So to take the cube root of something on the TI, we're going to have to tell it what kind of root to take. We want to take the 3rd root. Well, the 3rd root of what? Now we're going to go second. We're going to hit the exponent button to give us access to that. And it's going to open up similar to what my Casio did. It's the xth root. It will use this number that you put out front here and take that. So this, writing it like this, is the 3rd root of 125. So that is 5. So similar now to square roots, we can find cube roots of fractions and decimals. Sorry, we're good? Okay. So the cube root of 1 over 27 is, we're doing it the same way we did the fractions. So or the fractions and the square roots rather. When we had the square roots, we wanted to know, is the numerator a square root or a perfect square? Is the denominator a perfect square? When we're taking cube roots, I wanted the same thing. Is the numerator a perfect cube? Is the denominator a perfect cube? Well, in this case, is 27 a perfect cube? Well, it's listed right here. The cube root of 27 is 3, so 27 is one of these perfect cubes. So then, likewise, this thing is 2. I can break this thing up into the cube root of the numerator over the cube root of the denominator. So the cube root of 1 over 27 is going to be 1 over 3. Now, I gave you slick ways to do decimals and perfect cubes. I'm not, or on perfect squares rather, we're not going to do decimals and perfect cubes. We're just going to get rid of that. Pretend like it never happened. Or the only other thing I will ask you to do is to be able to ram that thing through your calculator. It would look like, on my Casio, it would look like this. 3, nope, I have a cube root button, so let's use the cube root of 1.125. It's not a perfect cube because this goes on forever. This is 1.0400419112 ... It just goes for it. What are you doing, Liam? At least pretend to take notes. You weren't here yesterday when I said it, but if you can't be bothered to take the notes that we're taking and pretend to, when you got questions, then don't ask for help, because if you haven't tried to engage, then I'm not going to waste my time reteaching it. Okay, on your calculator, the Sharp. Okay, pass that bad boy over. On your calculator is the same as the TI. You have the X root button right there. Yeah, it's the same one, yeah. What's that one? What's it say? Tell me what it says.
Oh wait, yeah, it doesn't say.
What is the button? So you have, no, that's going to be, okay. So you either need to have, so you, Rabin, need to use what I did before, the X root button, or a dedicated cube root button, or a box root button. If you just put 3 and then the square root, it's going to go 3 times the square root of whatever. It'll do BEDMAS the way BEDMAS is lined up. You need to use, on the Sharp calculators, you have this button, you must use that button. So you'll have to push 3, then the X root, and then your number. The Sharp works the same way the TI does. Yes. Yeah. Yeah. What? No, don't clear it.
Oh.
Why would you clear it when I'm going to look at it? I'm willing to bet I know what's going on here. Okay, so Raven, okay, pay attention to what I'm doing here. Your calculator works exactly the same way. Now, you're not pushing the cube root button. You're pushing this button, the Y to the X button. It's not the Y to the X button that you need. No, Raven, look, watch. You need this. That symbol above, Raven, watch. The symbol above the button, right? Now look at your calculator. That symbol's above the button, right? So it's just like what you did yesterday. When it's above the button, you have to go up here and push either shift or second function. Your calculator, they'll all do it a different way. Push this button, and then you push that exponent button you were trying to push, and it'll open up the kind of root you need. You needed a cubed root. Yeah. Yeah. And that'll give you this symbol. And then 125. Okay, so we didn't talk about this yesterday, but we're going to talk about it today. In lesson 5, we didn't learn this, so let's talk about it here. Can you square root a negative number? I left it off yesterday. Who said no? Okay, pick your head up if you're going to speak. Oliver, was that you? Why can't I square root a negative number? Because a negative times a negative is a positive number always. So we cannot square root a negative number because a negative times a negative is always positive. So like, for example, the square root of negative 4 doesn't make sense because I cannot multiply a negative number by itself twice rather, to get a negative number. Yeah? No. I told you when I was done, if you had to go to the bathroom at the beginning of class, you should have gone to the bathroom between classes. Instead, you sat here for a while. I want you guys to punch the square root of negative 4 into your calculators. Those of you who have a calculator, Jackson, pick your head up. You know, if you want to sleep, go sleep on the couch. What does your calculator say the square root of negative 4 is?
2.5.
Try it again. 2.5? You got an I on your calculator? What kind of calculator you got? A Casio fancy calculator. So if I want the square root, no, I don't want that. I want the square root of negative 4. This calculator says math error. The square root of negative 4 on this calculator gives me a domain error. Gershon's calculator gives you an I. Oh, Gershon's got a fancy calculator. The square root of a negative number doesn't work because you can't multiply a negative number by a negative number and get a negative number. Most of your calculators are going to give you an error. Sorry? Oh, I keep thinking you're talking to me, but you're clearly not. Gershon, your calculator gives you an I. Do you have any idea what that I means?
No.
Shobit, do you know what that I means? Yeah. There's a way, mathematicians developed a way to handle negative roots. And what we do, okay, and because your calculator, I wasn't going to show you this, but because your calculator has done it, let me introduce it to you. What it does is it says that the square root of negative 4 is equal to the square root of 4 times the square root of negative 1. The square root of 4 we can do. The square root of 4 is 2. Now the square root of negative 1 doesn't make any sense. Are you on your phone? Liam? No? Okay, cool. So the square root of negative 1 doesn't actually conceptually make sense, but we use it. We use it all the time. In engineering, in electronics, the square root of negative 1 is actually vitally important because we can square the square root of negative 1 and get negative 1. You can square something that doesn't exist and get a real mathematical value. And so we gave it notation. We say that the square root of negative 1 is actually I, so that the square root of negative 4 is equal to 2I, and this brings in a whole set of numbers that we call imaginary numbers. So most of your calculators are not programmed to handle imaginary numbers. Those calculators will give you an error, either a domain error or a math error every time. Gershon's got an awesome calculator that will handle imaginary numbers for you. And if you choose to, the two fields I've seen it most often are in electronics and in engineering. Imaginary numbers are actually wildly important. For those of you who are not interested in electronics or engineering, you'll never see this. Don't worry about it. Just know that a whole bunch of the real world is governed by imaginary numbers, and that'll be enough to hopefully give you a little bit of discomfort. So square roots of negative numbers conventionally don't work. But how about cube roots? Can I multiply a number by itself 3 times and get a negative number? Yeah. The cube root, rather, of negative 8 is going to be what? Negative 2. Because negative 2 times negative 2 times negative 2 equals negative 8. Multiplying two negative numbers equals a positive every time, so that's why we developed this field of imaginary numbers. This will always work. I'll say it this way. Odd roots of negative numbers. Oh, I'm using all sorts of symbols today. This stands for negative numbers. Odd roots, so third roots, fifth roots, seventh roots of negative numbers are allowed because you can multiply an odd number of negatives together and get a negative number. Even roots are not allowed. Even roots are where we jump into this world of imaginary values. So you need to know how your calculator works, which is why I told you at the beginning of the semester to get a calculator for yourself. Specifically, one of 4 kinds. I recommended them to you specifically in your course outline, because you need to be comfortable with how your calculator works. If you don't have a calculator, I want you to come up to the front and grab one of my calculators. Leave me your phone. Yeah, come grab one. If you don't have a calculator, come grab one now. Put your phone in the slot. Now I want your phone if you've got one. If you don't have a phone, I find it a little bit hard to believe, but if you don't have a phone, leave me your shoe. If I find out later that you do actually have your phone, I'll take your phone and I'll leave it down in the office for the day. And I want you to get comfortable with a calculator of choice. A shoe. Depends on where I keep it. If I have it, you'll get it back at the end of the class. If I send it to the office, at the end of the day. Then then you get it back when you give me a calculator back. No, I'm not done my lesson. Okay, so you've all got calculators. I want you to find this, whatever calculator you're using. I want you to find these 3 square roots and these 3 cube roots. Make sure you can get all of these values. You need to be able to do these 6. Figure out how your calculator works. If you need me to help you, call me over. I'll give you a hand. Okay, which calculator do you have? Which calculator? You a Casio? Okay, so this, oh, that's a decimal point. So you're looking for the symbols that are on the screen. So the square root of something. So is there a square root somewhere? Yeah, it's right there. So push that button. Push 9. 9, because you're doing this first question. The square root of 9. Okay, equals. There you go. Found a square root.
Jackson, you don't copy me, you do it yourself.
That's a cube root. Now what's this guy going to say? Square root of negative 100. Oh. Okay, yes, that was one button. So this guy, this work at 34. Okay. If you want to do negative 100, you put 100 first, and then you push this button.
Math error.
No.
Math error.
But error 2. You got a math error? Okay, I want to see your calculator. What kind of math do you
Right, I don't want to get black.
got? Imaginary numbers. Oh, you have the complex. You have it set to complex. So I turn that off. And you use the square root of negative 100. You want complex values, you don't show
What if you just didn't bring it to class?
How do you do minus 100?
I don't know.
Oh, I don't have.
Complex numbers are imaginary
Math
spaces.
error.
Usually
Math error, I did not.
Oh, wait, which one did you do? Third negative one.
If I ask you a question,
Yeah, not there.
Do I do cube root?
how you choose to answer those kinds of questions is not important. Because I wouldn't necessarily say, well, what's the square root of negative something? I would ask you something.
How?
The answer is
How?
yes. No, you kind of. No, you can't, because a negative number times a negative number is no good. But you kind of can, because we developed this world of mathematics called imaginary complex numbers. Deal with that.
Oh, bait.
No. What? No, you have to either know and then tell me why, or kind of explain. Okay. No, because we're not done. You have a human in two. There's 6. Okay, so write down error.
2.0800088.
Whatever the number is.
2.08.
You would have 9. Yeah, write that number down. Number down. Yeah, it's not a big deal. I will. Don't worry. I will tell you when you can leave. Yes. What's up? Yes. 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 That. Are we doing a show?
What did you get from this one?
Figuring things out over here?
How did you get that
Sort of.
one today?
Calculator you're happy with?
Please excuse this interruption, and I would like your attention to all staff and students. Please listen carefully.
Yeah, it's earthquake drill.
Today, we are going to practice a earthquake drill, also known as drop, cover, and hold.
No. Recording. There you go. This is what you're taking a look at. Sorry. Video who I paused. This is what you missed. Pause it now and write it down. There you go. Or take a look at my A block video. This page. Hayden, Mr. Glenn, you may go get a drink. Liam, you may go use the washroom. When one of them gets back, Jackson, you may go, if you've done some work between now and then. Otherwise, you're not going anywhere. Okay, get this page done. In 5, 10, 15 minutes. Yes, you need to use a calculator for some of these. For most of these, you'll need a calculator. But I still want you to show me your work. Like for these BEDMASI questions down here at the bottom, the simplifications you're making, show me the steps you're doing to get to these bottom ones. You will need a cube root. Okay, get going.